Good evening, all. Good evening. You're welcome to the tutorials with from Eternity the Schoolboy. Today, we'll take a look at chemistry, where we review of our last chemistry assignment. So without wasting time, we'll call out the questions. Okay, number one question says, which of the following substances is not a homogeneous mixture? Which of the following substances is not a homogeneous mixture? A. Filtered seawater. B. Soft drink. C. Flood water. D. Writing ink. Flavor. Flood water. Okay. Chine, why is it? Why is not a homogeneous mixture? Flood water. Mixtures have components. That's why they are mixtures. We are talking about. She said, Favor said that the flood water is not a homogeneous mixture. What is even homogeneous mixture in the first place?
A mixture is not even.
Okay, a homogeneous mixture is not even.
And it's not chemically bound. And new substances are not.
If Lonya, I'm not a homogeneous mixture. Oh yeah, what homogeneous mixture?
Homogeneous mixture is a type of mixture that have one phase. That is one. Yes.
It's
one,
even, uniform.
Yes.
Chinaya, you said you okay, Uchiya Batago. So homogeneous mixture is uniform, right? Just like sugar in water. Sugar will dissolve and form one phase. You won't even notice that there's something inside it. True of us. Once you have a mixture of two things and you don't notice that, in fact, you don't know that there's something else inside that they are mixed up, then that is a what? Is a homogeneous mixture because it just have one phase. So filtered seawater. If you filter seawater, ordinary seawater has other things involved, right? It's there. But once you filter it, it's only solution that will pass through. But in that solution, you say you have salt and water, the three of us. So it's a homogeneous what? Mixture. Soft drink is also a homogeneous mixture. If you have you ever opened a Coke, even though it's black or Fanta yellow, and you start seeing something inside it, will you drink it? No, that one is not a mixture. That one is not homogeneous now. I'm talking about soft drink. That one is not soft. I hope you know. It's just juice. I'm talking about soft drink, and they left that thing to show you that they want you to know that it's a real orange they use. That's why they left it there. Okay. If not, they would have filtered it out. True of us. But they want you to know that. And also, apart from that, roughage is also good for the system. So now. Soft drink like Coke, the one you drink, your Coke, your RC you drink, even though it's black, yellow, but it's homogeneous. True of us. If you open it and see one particle dancing inside it, will you drink it? Because it is expected to be what? Clear, right? So it's a homogeneous mixture. Then writing ink is the same thing with writing ink. Writing ink is also a homogeneous mixture. If writing ink doesn't contain, if writing ink has some particles, you may go and block. Let's assume the one in your pen now. It will go and block that place, and the pen will not write. I hope you know. So writing ink is a homogeneous mixture, but flood water is not. Flood water is a conglomeration of different things, both dissolved and undissolved. True of us. So flood water is, I agree with that. Flood water is not a homogeneous mixture. Number 2 says, which of the following is a physical change? A. Bubbling chlorine in water. B. Bubbling of chlorine into jar containing hydrogen. C. The dissolution of sodium chloride in water. D. The passing of steam over heated iron. Chineye? Dissolution of sodium chloride in water is a physical what? Change, because no new substance is formed. Still, what is formed with sodium chloride what? Solution. There's no, but other ones are chemical reaction. True of us, new product to be formed. So the answer is what? C. Number 3. Methanoic acid mixes with water in all proportions and has about the same boiling point as water. Which of the following methods would you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? A. Fractional distillation. B. Filtration followed by distillation. C. Neutralization with sodium hydroxide followed by distillation. D. Neutralization with sodium hydroxide followed by filtration. D is what? Filtration followed by what? Distillation. Yes. The first thing is to filter it. Once you filter it, sand will go through of us. The methanoic acid and water will enter and will come out as filtrates. You now distill it and recover your what? Solvent, which is what? Water. So the answer is what? Filtration followed by what? Distillation. Number 4 says, which of the following processes is a physical reaction? A. Electrolysis. B. Hydrolysis. C. Allotropic change. D. Neutralization. Chioma? Allotropic what? Change. Yes. All the other ones are not what? Physical change. They are chemical, because new substances are formed. But in allotropic change, it's moving from one form to what? Another form. But it is the same substance. True of us. So it's a physical change. Number 5. Classify each of the following as a physical or chemical change. A. Fractional distillation of liquefied air. Chinwendo. Fractional distillation, is it a physical change or chemical change? Physical change. Are you sure? Yes. Physical what? Change. Cracking of petroleum fractions. Favor, Adobe. The chemical change, because new product are what? Formed. True of us? Good. C. Conversion of rhombic sulfur to monoclinic sulfur. Chinaya? Conversion of rhombic sulfur to monoclinic sulfur is what? How? Explain how is it chemical change. Tell us. So rhombic sulfur is not said to be monoclinic sulfur. What is allotropic change? Physical change of what are you saying? Physical change of little state. Which one is it? Okay, it's change. So what? Form. Thank you. Now, what? Give us examples of substances that undergo such. And what else? Give us another one. Sulfur. So what forms does sulfur change? From which front and that for which front? Read that thing again. That thing, as I read it again. What is that? That's what you'll be saying here, sister. That sulfur is one of the substances that undergo allotropic change. That is the allotropic change of sulfur from one form, monoclinic form, to what? Rhombic form. It's not. So that is what is called what? Allotropic change. So is it a physical change or a chemical change?
It's chemical change.
It's a physical change now. It's in sense sulfur, no change, no new substance. It's sense sulfur. The same way carbon change from one form to another form and still remain the same carbon. It's still carbon. It doesn't change anything. True of us. So that is a physical change, not chemical change. Please correct it, please. If you, I hope you all wrote this in your notes. You did it in your notes. Then this says chromatographic separation of chlorophyll. Success. Physical change, yes. Chromatographic was separation of chlorophyll is a what? Physical change. All right, let's continue. Number 6 says the purity of a solid sample can be determined by its A, boiling point, B, melting point, C, conductivity, D, solubility. Chioma. Melting point, good. Because if you say that, Chioma, what happened to the melting point of a solid if it is impure? Do what? Increase, decrease. Good, thank you. So melting point will do what? Decrease. So the answer is what? B, melting point. Number 7 says state 2 criteria for determining the purity of a substance. Chinwe, state 2 criteria for determining the purity of a substance. Melting and what? Good. Constant melting point and constant what? Boiling. These are the basic one. We can have density, refractive index, and whatever. But these are the 2 basic ones. If they ask you to hit these 2 points, okay? First, before anything. All right. Number 8 says, in which of the following are the substances arranged in their correct order of increasing melting point? In which of the following are the substances arranged in their correct order of increasing melting point? A, sodium chloride, sulfur, diamond. B, diamond, sodium chloride, sulfur. C, sulfur, sodium chloride, diamond. D, diamond, sulfur, sodium chloride. Michael, what's the answer? C is what? Sulfur, sodium chloride, and what? Diamond. Diamond is stronger than what? Sodium chloride, followed by what? Sulfur is the least. So because of that now, the melting point of sulfur is lowest, followed by the melting point of what? Sodium chloride, and melting point of what? Diamond. Thank you. Number 9. Explain briefly why water has a higher boiling point than ammonia. Gangan. 7. Gangan. Take marker and explain it. Come to the board and explain it on the board. Madam, come. Take marker. Go to the board and explain it fast. Don't say by your mind. Go to the board. Take marker. What marker is on the board? Explain why. Use structures to explain why. Okay. Oh yeah, start. Oh yeah, let's hear you. Oh yeah. Let's hear you. Oh yeah.
Higher boiling point than ammonia.
Why water has higher boiling point than ammonia?
It's because it's due to the hydrogen bonding in the ammonia. Yes, it has a lower boiling point than water. That is, ammonia has a lower boiling point than water. And hydrogen bond in water is stronger than that in ammonia, both in number and energy.
Why? What makes it stronger in water than ammonia?
Because it has less hydrogen bonding.
Huh?
It has less hydrogen bond.
Which one has less hydrogen bond?
It's ammonia.
Why does it have less hydrogen bond?
It has
Why
less,
does ammonia have less hydrogen bonding?
because it has lower boiling point.
Why does it have lower boiling points? In a way, naturally. Why does it have lower boiling point?
Okay, because it is reinforced by the polarity of hydrogen bond, OH. This is where I can stop. I don't know anything.
You try, Sha, but you didn't get the reason. You know I say it, don't accept anything until you see, until you know the what,
Remember.
the reason. That's why you're a scientist. Don't just accept anything you see. You must try to get to a logical reason why that thing it was happened. Have you heard of lone pair of electron? Lone pair, right? Good. Anyway, we'll still do chemical bonding anyway. I think that should be our next topic, sure? Atomic structure and chemical bonding, right? And bonding, right?
Yes.
We'll do atomic structure. After atomic structure, we'll now enter what? Bonding. When we get to that place, we'll talk more about. But I want to describe something. I want to explain something on the board. Look up. Lone pair of electron is that electron that is not involved, that is not shared. Okay? It's an electron that is not what? Shared. It's a pair of electron that is not what? Shared. Now, in ammonia, actually what happened is this. Water molecule, a molecule of water has two lone pairs of what? Two lone pairs of electrons that are readily available for hydrogen bonding with other water molecules. But ammonia has just one lone pair electron. So that what it means is that the number of hydrogen bonding water can form is small to compare with that of what? Ammonia. That makes it to be what? Stronger. Am I completing? In an attempt to break this bond, this intermolecular forces, that the temperature will be what? Higher in a what? Water than in what? Ammonia. So that's why water has a what? Higher boiling point than ammonia. See what I mean by lone pair of electron? You know, hydrogen atom is something like this, right? An hydrogen atom has just one what? Electron, right? Yeah. Good. Now, this is hydrogen atom. Sit up, Ching, when you're sleeping. This is what? Hydrogen atom. Now, you know water is this, right? Water is this, right? Then oxygen atom is this. Is bigger, right? Oxygen atom has two electrons inside here. Two of us. The inner shell is what? Oxygen has atomic number of what? 8, right? Right? So it has 2 inside the first shell. Then the outermost shell has how many electrons? 6 electrons. So in pairs, you have things like this. Let me shade that of hydrogen. That of hydrogen is shaded. Things like this. See what you have. Right? Then, this is another what? Hydrogen atom. This is what? Hydrogen. This is what? Hydrogen. This is what? Oxygen what? Atom. See what happens there. You know, in covalent bonding, the idea in covalent bonding is to form a stable what? Octet or what? Duplet what? Configuration. Hydrogen is struggling to attain a duplet configuration. Oxygen is trying to do what? Attain a what? An octet what? Configuration. So they will share. So this hydrogen will donate its own. So as you are sleeping, hydrogen will donate its own what? That one electron it has. Oxygen will bring one. They will share it, and as they are sharing now, hydrogen will become what? 2 octets. Sorry, duplets. Now this is what happened. Now when they now combine, you see something like this. Oxygen will share. There are 2 electrons inside. Remember. Now this hydrogen here will combine with this one is from hydrogen. This one is from where? Oxygen. They will combine. This one is from where? Hydrogen. This one is what? Oxygen. They will combine. This is oxygen, hydrogen. So if they combine, see what will happen here. Oxygen, hydrogen here is completed 2. 2 completed. What remain here is what? We have 2, 3, 4, 5, 6. 2, 3, 4, 5. 1, 2, 3, 4. This is inner shell. What will remain here is only these 2 pair of what? Electron. These electrons are not shared. They are called what? Lone pair. Are we together? So you have 2, 4, 6, 8. Oxygen is what? Complete. Hydrogen is 2. Complete. 2 complete. They have completed their what? Respective duplet and are you listening? What are you copying? They have completed their respective octet and what? Duplet what? Configuration. Now, this atom, this electron here now, there are 2 pairs, right? This is a lone pair. Lone what? Pair. This is a lone what? Pair. This is a water. This thing you see here now is a water molecule. 2 hydrogen and 1 what? Oxygen. This is a water molecule. 1 molecule of water. This is it. Now, this electron and this electron that are empty, that are lone without being shared, are available for formation of hydrogen bonding. You know, if you have a bit of dipole, positive, partial positive, polar, a bit of a thing like this, no one will describe it. This thing will form a bond with this. So this is available with. That means what it means is that about how many halogen bondings can be formed here? 1, 2, 3, 4. 4 extra what? Hydrogen bonding can be formed with other water molecules. Am I communicating? Now, but let's look at ammonia. Ammonia has this is formula for ammonia. NH what? 3. 3 atoms of hydrogen and 1 atom of what? Nitrogen. See what happened? Nitrogen is bigger. Nitrogen has atomic number of what? 7, right? The inner electron is what? 2. The one that will be on the shell, outermost shell is 5. 1, 2, 3, 4, and what? 5. Look at this. Look at hydrogen. Let me put 3 atoms of 3 atoms here. 3 hydrogen and what? And what again? Hydrogen. The same thing here. Hydrogen is struggling to attain what? Duplet. Nitrogen is struggling to attain what? Octet. See how it will happen. Hydrogen will bring its own 1. Nitrogen will bring 1. They will bond. This oxygen is this hydrogen is completed. Then the same thing will happen here. See what will be formed. You see something like this when they combine. You see something like this. This is say what nitrogen. You have this one will combine with one here. You have something like this. This is for hydrogen, nitrogen. You have electron from hydrogen. Sorry, the one that is shaded is from hydrogen. The one that is not shaded is from where? Nitrogen. You form this. Shaded is from hydrogen. Non-shaded is from where? Nitrogen. These things are hydrogen, hydrogen, hydrogen. Watch out. This hydrogen is already completed, duplex. This one is completed, duplex. This one is completed, duplex. What of nitrogen? Is it completed? It's struggling to complete 8. Let's count it. 1, 2, 3, 4, 5, 6. It's not completed, right? It remains what? 2. So this 2 is a lone pair. So nitrogen, this ammonia has 1 lone pair electron. Water has what? 2 lone pairs. So this one can form 2 hydrogen bonding with other molecules. Am I communicating? But this one will form 4. And the more hydrogen bonding is formed, the stronger it becomes. The more the boiling what? Point. So this one, that's why this water has what? More boiling point than what? Nitrogen. Is it clear? By the time we do bonding, you understand it better. But I just want to use it to prepare our minds. Chill, get up. Plot. Thank you. Get up. Be walking around. Success. My eyes are on you. Or I'll be walking around. So that's why water has higher boiling point than what? Ammonia. Number 10 says, which of the following separation techniques would show that black ink is a mixture of chemical compounds? Where do you stop? Which of the following techniques, number 10, will show that black ink is a mixture of chemical compounds? A is crystallization, B is chromatography, C is filtration, D is sublimation. What's the answer? B is what? Thank you. We just discussed that one in our last class. So the answer is what? Chromatography. All right. We have come to the end of our chemistry assignment review 6. Chemistry assignment review 6. If you have any question, please ask. Any question? Any question? Ask. Any question? All right, in the absence of... Okay, he has to sit down. To do what? Uh-huh. Two hydrogen. I don't understand your question. No, it can form 4 hydrogen bonding. Yes, because of the 2 lone pairs, two lone pairs of electron, 2 lone pairs. Yes, this one can only form 2. Is it clear? Is it clear? Okay. Shared, as you can see. Remember here, these ones are shared now. The shaded one came from hydrogen. The unshaded one came from oxygen. Is shared. Is sharing. They are sharing it. This one is complete. Two electron. This one is completed. So they are shared. But this one is not shared. That's what I call lone what? Pair. Lone pair. Don't worry, by the time we enter bonding, you will understand it better. I just want to use it to prepare our mind towards that, okay? Okay.
Is there any method that can use any mixture that can use separate that can be separated
That one is purely chemical reaction. You are going into something else. Okay? Are you there? Or do you have any idea of what you use it to separate? It's a chemical reaction. A lot of once chemical reaction has occurred, a lot of things may go in. Okay? A lot of things may do what? Go in, because before bond can be formed, bond must be what? Be broken. Hope you know. Chemical reaction is all about bond what? Breaking and bond what? Formation. Before a new bond can be formed, another one must be what? Be broken. Is it clear? But you know that separation is just using physical difference in the physical what? Properties. Huh? Huh? Is that how to stand up? You are sleeping. And make the success. You can sit down. Sit there, because it seems this shit make people to sleep. Sit there. Alright, so I think we'll stop here. We'll come to the end of our review. Chemistry review 6. Alright, thank you very much for your attention. God bless you.